Welcome to this explainer. I am absolutely pumped for this one because, well, we're building something you've probably been looking for. The ultimate hyper-focused statistical tool belt. Literally, all the essential formulas and core concepts packed into one single masterclass. Think of this as your definitive cheat sheet. Whether you're gearing up for a massive data project, cramming for an exam, or prepping for a strategic meeting, you are exactly where you need to be. We're going to cut through the heavy math and focus purely on the so what these numbers actually tell us about the real world. Let's get into it.
Okay, let's dive into this roadmap. We've broken the heavy lifting into 5 clean, logical tool sets. We'll hit central tendency, dispersion and shape, core probability, random variables, and we'll wrap it up with transformations.
Section 1. The core central tendency. This is our foundational tool. It's all about summarizing what just happened by finding exactly where the data is concentrated.
All right, here are your 3 heavy hitters, so definitely take a screenshot of this for your personal cheat sheet. The mean is simply the sum of everything divided by n, the total number of observations. Then you've got the median, which finds that exact 50th percentile, the literal middle of your sorted data. And finally, the mode is just the value that pops up the most. Super fast, punchy, and absolutely crucial to get down.
Moving on to Section 2. The spread, dispersion, and shape. Because, just knowing the center isn't quite enough. We actually have to measure the risk and the variation around that center.
So here is your dispersion toolkit. We've got the formulas for standard deviation, variance, range, and the interquartile range, or IQR. But let's pause and talk about the why before we get lost in the math. Look at that variance formula. Notice how we square the deviations from the mean? We do that completely on purpose. By squaring it, we stop negative and positive outliers from just canceling each other out to 0. It forces every single deviation to count towards our total measure of risk. Now let's slow down for just a second, because these next 2 are incredibly powerful advanced shape metrics. Data doesn't just spread out, it takes on very specific shapes. Skewness tells us about symmetry. Does your data lean heavily to one side? And kurtosis, well, that measures the peakness and crucially the thickness of the tails. Let's look at what this actually means visually.
And this brilliantly illustrates the concept. Look at that perfectly symmetric curve right in the middle. The mean, median, and mode are all stacked perfectly right on top of each other. But then check out the positively skewed distribution over on the right. Do you see how the mean is literally being pulled away from the peak, dragging out toward that long tail? Outliers drag the average with them. That is exactly why the median is usually your safer bet when dealing with skewed data.
All right, now for kurtosis. On the left, we've got a leptokurtic distribution. Notice that really sharp peak in those very thick, fat tails. Then on the right, a platykurtic distribution, much wider peak, super thin tails. In the business and finance world, leptokurtic is a massive red flag. Those fat tails mean that extreme outliers, those rare black swan events, are lurking out there with a much, much higher probability than a normal curve would ever predict. It's a game changer for understanding risk.
Let's tie dispersion and shape together with a classic box plot. This beautifully maps out the spread we were just talking about. The edges of that box are your lower and upper quartiles, Q1 and Q3. The box itself, that's the interquartile range, the IQR, and it holds the exact middle 50% of all your data. The whiskers extending out show you the highest and lowest values before you start hitting those crazy extreme outliers. Let's transition into Section 3, Navigating Unknowns. Core probability. We're moving energetically from describing past data to calculating the likelihood of future events.
Once again, all your essential formulas are right here on one slide for your cheat sheet. We've got conditional probability, joint probability, the law of total probability, and the legendary Bayes rule. Now, I know these formulas look incredibly dense, but let's ground them in reality. Bayes' rule is simply the mathematical process of updating our beliefs based on new evidence. It's basically just asking, okay, now that event B has happened, how does that actually change the probability of event A?
To show you just how counterintuitive and powerful this is, let's look at the famous Monty Hall problem. Imagine you pick one of 3 doors hoping for a car. Your initial odds are exactly 1 in 3. Now, the host, who knows what's behind the doors, opens a different one to reveal a goat. He then asks if you want to switch your choice. Most people think, well, there's 2 doors left, it's a 50-50 split. But there's no way. Because the host was literally forced to reveal a goat, new information just entered the system.
Mathematically, Bayes' rule proves that switching actually jumps your odds of winning to 2/3. You should absolutely always switch.
Let's apply this to a real-world business case. Say you buy 65% of your parts from supplier 1 and 35% from supplier 2. Supplier 1 has a 98% good yield, and supplier 2 has 95%. Suddenly, you find a defective part. Who's to blame? Let's walk through it step by step. Step 1, find the actual defect rates, not the yield. Step 2, use the law of total probability to figure out the overall chance of any part being defective, which comes out to 0.0305. Step 3, we use Bayes' theorem to trace that specific defective part backward to supplier 2.
Now, what's really interesting about this slide is this final result, 57.38%. Think about that. Even though supplier 1 provides the vast majority of your parts, a defective part is overwhelmingly more likely, almost 58% likely, to have come from supplier 2. A tiny 3% gap in performance makes the lower volume supplier the absolute primary culprit. It just goes to show, probability overrides sheer volume every single time.
Section 4. Scaling up. Random variables. This is the bridge that maps real-world outcomes into numbers we can plug right into our predictive models.
We essentially divide the world into two types of variables. Discrete variables are countable and exact. You can sell 5 chocolate bars or 6 chocolate bars, but you can't sell 5.67 chocolate bars, right? Continuous variables, on the flip side, cover an interval with infinite possibilities, like measuring a constantly fluctuating stock price down to the micropenny. Discrete uses a probability mass function, while continuous uses a smooth probability density function. Here's your cheat sheet for random variables. Whether your data is discrete or continuous, we still have to find its center and spread. For discrete data, we use sums. For continuous data, we use integrals. But remember our callback from earlier? Expected value is literally just the mean we learned way back in Section 1, just evolved to handle future probabilities by weighting each outcome by its likelihood. It's the exact same core concept. Section 5. The rules of transformation. Let's move to this and see how this builds our final toolkit for manipulating entire datasets all at once.
This final table is an absolutely crucial part of your cheat sheet. If you add a constant c to every number in your dataset, the mean simply shifts by c. But the crucial point is, look at the variance column. If you add a constant, the variance stays exactly the same, var x. Why is that? Because adding a constant just shifts the entire dataset up or down equally. The spread between the data points remains utterly identical. A constant has 0 variance.
And there you have it, the whole shebang. We've covered the central tendencies, the shapes of risk, the laws of probability, and the rules of transformation. You now possess the ultimate statistical cheat sheet with every essential formula logically mapped out for you. The only question left is, how will you apply this incredibly powerful toolkit to uncover the hidden stories in your own data? Thanks for joining me on this explainer. Now get out there and conquer your numbers.